at such short notice. It's great to be here. All right, so what I'm going to talk about today is essentially a mix of several papers that have been accepted, some things that are currently under review, and it's basically a trying to be a whole picture of what the influence of extralinguistic factors on NLP could be and probably is. So let me start out to motivate this with a very rhetorical question. Does anybody really expect these two people to use language exactly the same? Probably not, right? Old people always complain about, oh, the kids these days, you can't understand them, and like young people don't know what older people are talking about. So in our everyday life, we do not expect different demographic groups, be it age or gender or other factors, to use language exactly the same way. We accept the fact that different people do speak differently and that there are group-specific differences. However, that's not what we train our models, our NLP models, to do. Basically, our models are like people who walk around and assume that language is uniform and that everybody speaks the same. What we do is we sample from a distribution and then we expect that that somehow approximates the true underlying distribution and that that's what we get and that we can use that to actually model language. However, what if the actual distribution looks more like this? The problem with this is that the thing we sample from in NLP more often than not is restricted to, say, the Wall Street Journal. And that is a very specific demographic that is written by and for people who tend to be more educated, slightly older, and predominantly male. And that other domains that we now work with increasingly in NLP, such as Twitter, are a lot more varied. They're a lot younger, ethnically diverse. People are not necessarily as affluent. What we do in NLP is we do domain adaptation. We say, well, let's train our models on the Wall Street Journal, and then we adapt to Twitter because Twitter is just weird and it uses strange language. The question I want to raise in this task is maybe we shouldn't do domain adaptation. Maybe we should more care about demographic adaptation. The question is, of course, why should we care about this? And the big issue here is fairness in NLP. So what we see here is a map of the United States with the log likelihood assigned by a post tagger for tweets from the different states. And basically the lighter blue, the better, the log likelihood. Negative log likelihood. The problem comes when you focus on certain varieties. So what we did is we looked at tweets that contained certain phonological equivalents of African American vernacular English, such as street becomes screet, or brother like written in a different way, th becoming f, things like that. Suddenly, the states that have a lot more African American authors receive a worse log likelihood. So our model does not is more surprised. Our model does not deal as well with data from this background. So if you're a speaker of African American vernacular English, NLP is gonna do worse on texts from you. Opposite, if you look at data that does not contain these particular features, the model does a lot better and it has a higher confidence in it. Well, people have pointed out, okay, so this is mainly a vocabulary problem, which is true. Our data selection was based on vocabulary items, was based on differences in spelling, but the problem goes deeper. So in a paper that is currently under submission, what we looked at was what is the difference between post tagging accuracy for reviews from a younger group and reviews from an older group, and we did that for German and for English. And what we see using two different post taggers and averaging, we actually get worse performance on the younger group in both languages, significantly worse performance than for the older group. What does that mean? Post tagging is one of the first steps in every NLP pipeline. if our models do worse on language from people from a younger group, which is typically the groups where language change originate, it does not bode very well, A, for the future of our models, which means we need to update them constantly, but it also doesn't bode well for the users, because it means that those people will be systematically disadvantaged. We know that problems at the beginning of a pipeline snowball and basically incur larger errors down the line. So if you're disadvantaged as pos tagging, you're probably also not going to reap all the benefits of a full NLP pipeline. As NLP gets used more and more in policy decision making, in business analytics and other fields, this can actually have a real impact on people's lives.
What are Q35 and 45?
Oh, sorry, those are the age groups under 35 and over 45. I'm going to talk a little bit more about why those two groups in a bit. Yeah. So basically what I'm trying to do today is to look at the intersection of social linguistics, which is the field I originate from, which is where I did my undergrad, and then natural language processing, which is where I moved into. And then I'm sitting happily here in the middle, and this is also where the talk sits. And what I believe is that this is a good place to sit, because we can mutually inform the two fields with the information that we get from one or the other. In social linguistics, we have informed linguistic hypotheses. We know from social linguistic research that different groups use language systematically to ensure their group identity and that they differ, but it's oftentimes not statistically powerful enough. It's not quite the hard, rigorous data that we'd like to work with. And then on the other hand, we have large-scale statistical analysis methods. We know what to do with a lot of data, but we sometimes don't know when we have a finding, where did it come from, what are the underlying factors, what is the why. And basically what I want to do is use both sides to make the other one stronger. This leads us to a number of steps that we need to perform, and also is the outline of the talk, very conveniently. First, we need some data that actually contains information about the different demographic groups and has enough textual material. So that's the first part. We found some of a data source for this, and I'm going to talk about what we did to it and whether it's actually representative. This is work that we recently presented at DubDubDub in Florence. In the second part, we're going to go one way, and we're actually going to use large-scale statistical analysis methods, feature selection methods, to find demographic change in a data-driven way in that data set. And then in the last part, I'm going to present some work that has been accepted to ACL, which is how I got into touch with Mark, where we basically try to incorporate demographic information in a number of text classification tasks and see how that can help NLP performance. All right. By the way, if there's any questions at any point, please stop me and ask. Otherwise, I'm just going to steamroller on. All right. So first, we would like to have a data source that gives us text and that gives us demographic information. In NLP, we know what to do with text. We're good at that. We have all the tools, give us enough text, and we can do anything. So if we have something like this, the interesting thing would be now to actually look at how do certain textual features correlate with certain demographic features. So for example, the fact that there's no nose in the smiley might indicate that the speaker is maybe 34. The use of totally could also be a hint. It could also hint that this speaker is male. The use of a long drink, like a compound word written in one rather than in two parts, could indicate that the speaker might be German. And then the fact that words is ambience and the fact that they're talking about bars might indicate a college education. And then if we have that data, we can basically look for patterns between the meta information on top and the textual information at the bottom. The problem is that usually we don't have the information at the top. So what do? Well, what we did was we went to the web and found a website that's called Trustpilot. It's basically a review site where people go and they say, I bought something at denmark.com. It was a leash for my dog. The leash is pink with red stars, and it's wonderful, and the dog loves it, and we're all very happy. And they do that actually not only in one country, but this website exists in 24 countries in 13 different languages, which is great, as we'll see in a second, because it allows us to look at changes that hold not only in one language, but actually across different languages. What we can then do is actually crawl the web and extract the information. There's three entities that we're interested in. One is the users. Those are the blue guys at the bottom. The users leave reviews for the companies. Companies are the factories on top, and the reviews are those star ratings. And we can crawl this data, collect it for each language, and we have it as in JSON format, so we can easily access it and look for the subsets that we're interested in. The question now is, of course, how good is this data? How representative is this data? What we see is that for all the countries where we have more than 10,000 users, there is quite a Zipfian distribution. And the countries vary a lot in terms of what users reveal about themselves. So users have a profile where they log in with a name. Oftentimes it looks like a real name, but they can also supply information about their age, actually their birth year, which is very convenient, their gender, and the location they presumably live in. What we see is that Denmark, where the site originated, has actually a lot of users. Denmark is tiny. It doesn't even have 6 million people living in the whole country, but apparently more than a tenth of them use this website. And they're really forthcoming about letting you know how old they are, what their gender is, and where they live. So that's really convenient. In absolute numbers, we actually have more information about the users in Denmark than we have for a much, much larger country where we have more users like the United Kingdom. And you see the United States is roughly on par in terms of total users, but they're less forthcoming with their information. Still, if you add all this up, for each of those categories, we have several hundred thousands to millions of reviews, which translates to millions of sentences for each of those countries, and then for languages. Yes, Mark?
Do you have an idea why Denmark stands out so much?
I have, well, one is simply time. The website started there, so we have more, it's a longer adaptation period, so people have used it for, I believe, 7 years there, rather than 3 or 4 years in the US. So that's one thing. The other thing is that the general policy, or like the general approach to privacy in Denmark is very different to other countries. If you look, for example, at Germany, Germans are famous for not wanting to release information about themselves. It's a huge issue. Danes are a lot more unconcerned with other people knowing about specifics of them. So they don't probably perceive it as much as a problem to leave a lot of information there. So there seem to be some cultural differences as to how much information people provide about themselves. And then the other factor is how long has the website been active in these countries. Yeah. All right. So now the question is, of course, we have all this data. Can we actually rightfully infer things from this, or is it divorced from the reality, the real distribution of the population, the speakers of a country? So we looked at the regional distribution. On the right-hand side, you see the distribution across Germany. The larger the point, the more users in a specific location. And pleasantly enough, this looks a lot like the population density map over Germany. You see all the large countries, Berlin, all the large cities, Berlin, Hamburg, Frankfurt, Munich, and so forth, light up as large centers, and everything else is very reasonable. Now, very reasonable is not a category that we'd like to put in a paper. We'd actually like to analyze things quantitatively. So what we did is we compared the different NUTS regions. NUTS is a French acronym for nomenclature of units for territorial something. Yes, so it's NUTS regions. And we can compare the official numbers for those regions, like how many people are supposed to live there to how many users do we have in our data. What we see is that that tracks pretty closely. We have a few outliers. Berlin is a little underrepresented in our data in terms of the real distribution, but otherwise the numbers are extremely close. So that's great. We can look at the US. Actually, if we zoom on the eastern seaboard, we see that there's a fairly good distribution. Again, larger cities have more users. No surprises there. We also looked at the distribution over age and gender for the different countries. The first thing we see is that in all countries we have more male users. Those are the pink guys, than female users. Those are the yellow ones. However, the distributions do look a lot like what you'd expect from an age pyramid. And in fact, if we compare the median age in our data to the median age from the CIA fact book, for both genders, what we see, we get a mean average error that's under a year. So this indicates that the data we have tracks the true distribution in the population relatively closely. We did one more thing to the data, which is going to come in handy in a few slides from now, namely we dependency parsed it. So first we ran a pos tagger on it using the universal pos tag set, and then we trained state-of-the-art dependency parsers and ran it on the data. And we did that for a number of languages. I think we had tree banks for 12 different languages, or countries in this case. So in the first part, I showed you the data that we're going to use throughout the rest of the talk in the experiments. It has good geographic coverage and it tracks relatively closely with age and gender, so we can be relatively assured that the findings we have there are correlated with the true differences that we would find in the population as a whole. Great. So now we have the data, and what we're going to do in this part is we're going to see, can we actually use data-driven, large-scale statistical analysis methods to find differences between demographic groups? If we don't, then the whole thing is in vain, because if there's no differences, then why should we even bother about it, right? Social linguistics tells us, yes, there is differences. What did social linguistics do? Well, one of the seminal studies was by William Leboeuf. He went to different department stores in New York City and asked the clerks there, where is the men's clothing? Or whatever was on the fourth floor, because William Leboeuf was not really interested in the men's clothing or whatever was on the fourth floor, but in the clerks uttering the phrase fourth floor. Now, in New York, you get something called R-dropping. And R-dropping is typically associated with class. So when you go to an upscale department store like Saks on Fifth Avenue, people would not drop any R's. They would basically say fourth floor, with all the R's in erotic variety being in there. In Macy's, people would drop some, so you'd get like fourth floor or fourth floor or whatever. And when you went to S. Klein, which is now defunct, there would be almost no R's. So you get the fourth floor. So as the prestige of the shop went up, the number of dropped R's declined. This was one of the first papers in social linguistics. It was a huge hit. And it was great because you could actually see this correlation between extralinguistic factor and linguistic behavior. The difference is that William Leboeuf knew exactly what he was looking for. He already had that hunch, he already had that hypothesis. He only wanted the confirmation of that. Nothing wrong with it, but that's not exactly what we're after. What we want to do is actually use data-driven methods on our data set. So I'm going to show you a number of things that we found. One, or the first one, is actually not particularly linguistic, but it's a lexical item, namely emoticons. What we find is that there's a difference between whether you use a nose or not. And basically, there is one point where the use of a nose it overtakes the use of no nose, and that's around 34. So if you're older than 34, there's a higher chance that you actually use noses in your smileys than not. So this is the point typically where people start checking, what did my friends send me? Do they use noses or not? And that allows you to have a hunch of how old they are. The thing in general, you see the total line on top. declines over time, so there's a strong anti-correlation with age, or the older people are, the less likely they are to use smileys overall. So this is a new finding in terms of social linguistic variation between demographic factors and language use. Yes?
Is this really birth year rather than age? I mean, is it an age thing or is it like birth year?
It might be a birth year thing. So if we do the same thing in 10 years, it will probably have moved further to the right. Yeah, but at the time of writing, this cutoff is at 34, and it's like a really nice crossover point, right? Svetlana? Oh, okay. We didn't split it up by country. This is actually averaged over the countries. Yeah, that's a good idea. Yes. So another thing we did was we actually looked at regional varieties. So in Danish, there's this word called træls, which means something like, oh bother. It's sort of a mild swear word that's okay to use, but it's also very regional. The interesting point is if we plot sort of how often do people use it in these nuts regions across Denmark, we see the bluer it is, the more it is used. And like the western part of Denmark, which is sort of known to be a little more rural, people make a lot of fun of it, and it's the birthplace of træls. This is where people still use it on the internet, right? So their regional identity carries over to their online presence. And as you go east, you see people basically stop using it altogether. So this is essentially a new data-driven finding that we can get from our data that corroborates long-held beliefs in social linguistics, but it was not driven by hypothesis. So earlier on, I said that we parse the data, and this comes in handy because what we've done so far is we've looked at the lexical level. However, there is a theory in social linguistics which says we believe that syntactic structure or the use of syntax varies a lot across demographic groups. However, this is so complex we could never ever investigate this because we'd need too much data and nobody could ever do that. But we do strongly suspect that there is something. Well, if you use a computer, turns out you can actually do it. So what we do is first we extract syntactic constructions. What we mean with syntactic constructions is basically treelets. We cut out parts from those parse trees. Singlets are basically just the pos tags or the pre-terminals. One-step treelets are things like this, where there is one arc in between two tokens, and then two steps are obviously larger constructions. Prospectively, we would like to go even bigger, but as the study is so far, this is sort of the level at which we look. The question now is, do these features, do these syntactic constructions correlate with demographic groups? Well, of course, you could just go through. We know the age and the gender of the different posters. We could go through and just count it up. However, there's a problem with that. These features are highly interrelated. They're correlated. Since you have the singlets, the one-step and the two-step trees, each two-step tree is basically two one-step trees and three of the singlets, right? So these features are all correlated. And if you do that, you get confounding factors, and basically your statistics are not going to be very telling. So you want to tease these things apart. We have between 500,000 and 1 million different features in the data. We suspect that not all of them are interesting, but if you just do simple counting, that might get swamped out a little bit. What we do is basically feature selection. So we train logistic regression models, and then we look at which features get high weights. We're not interested in training a predictive model. We're just going to use those treelets as the features. We know what the target variable should be. We have hundreds, thousands of data points, and we can fit a logistic model relatively easily. What we do is yes?
And the target variables are like gender?
Yes, gender or age. Yes, in this case binary. It could be n-ary, right? There's nothing to prevent us from doing that. Here it is, yeah. What we do is we don't just do this once. We use something called stability selection, and basically what you do is you run or you fit a logistic regression model 200 times, right? What you do each time is you regulate it and you set the regulation factor. We use L1 regularization, and we set the regularization factor randomly. So how strong the regularization is, L1 should drive a lot of the features to 0, is sort of random in each run. And then you get feature weights for each of those runs. You can go through, and after 200, you can basically just average over them. Another thing is that in each run, we use a subsample of the data. So basically what stability selection does is it says which features receive an average high weight no matter what the exact data composition and regularization factor is. So which features do get a high weight no matter what the exact conditions. And those features we should be, or we can be relatively sure in, are predictive discriminative features. We ignore all the ones that receive a negative weight and then focus on those that get a high weight. For those, we look at, do they differ significantly between the two groups in each variable? So this is male and female for gender, obviously. And for age, we use under 35 and over 45. Why those two groups? Well, everybody agrees that young people and older people speak differently, but nobody knows where exactly the change point is. So what we did is we said, well, we want two equal-sized groups that are set apart by a bit, and it turned out if we use these two groups, we have roughly evenly sized groups, and there is somewhat of a separation. So we get representative groups. What we also do is we use Bonferroni correction because we have so many features. If you just do enough sampling, if you look at enough data points, you'll always find something that's statistically significant. So basically, we correct for that by Bonferroni correction. And what we do find is there are syntactic differences. Now, this should be obvious, but it's easy to forget as we go through. So let me say it explicitly. When I say there's a syntactic difference and group A does this and group B does this, it does not mean the other group does not use this construction at all, obviously. It just means group A uses this construction significantly more often than the other group, okay? But it's easy to forget, especially when you get excited about it. Yes?
Also, you could say, in this specific data set, for this specific
Yes.
population, and it's not, it may generalize to the whole population, right? But it may not.
But we can never know. So yes. The thing with significance tests is they always hold for whatever sample you have. We try to account for as many confounding factors as we can, so we normalize by the length of the data and the number of entries for each of the groups, because there's some difference. Note also that these things are at the syntactic level, so lexical differences do not enter into this. Okay? All right. So what we find is that people in the younger group use adverbial modifiers of verbs a lot. Well, that's great, but what does that mean? It translates, actually, if you look into the data, to constructions like ich empfehle sehr or recommend highly or recommande vivement, which is basically the same thing in different languages, which makes sense in a review setting. Of course, there's other phrases that have the same structure. In the older group, we find a more complex structure, which, again, by itself probably doesn't make intuitive sense. But if you look at it, it is something like im Vergleich zu, or within a couple of hours. So not hours, but within a couple of. What we also find is that these differences not only hold in one or two languages, these differences are actually the same across 7 languages. So this is a pan-European phenomenon, if you will. So it seems that there is something about the age groups that holds irrespective of the language, which makes sense if it's an extralinguistic factor. Now, let me repeat. Social linguists have long suspected this, but they never were able to investigate this due to the sheer size of the data and the complexity of the problem. Using stability selection and simple logistic regression models and enough data, we're basically able to find these things in a data-driven manner. The differences also hold between genders. So for women, we find a significantly higher use of pronouns. For men, we find a significantly higher use of numbers. These findings are not yet very surprising. We know that from work by Pennebaker and other people who have sort of looked at the individual token level. But then if we look at larger constructions, we find that women use significantly more verbal conjunctions, something like bestellt und war zufrieden, or was great and arrived, while men use noun compounds, something like customer service, or I don't need to explain noun compounds to this group, I assume. Again, this holds this time across between 9 and 11 different languages. So these differences are pervasive. And again, this is something that meshes with social linguistic theory, but this is the first time we can actually show it at a statistically significant level and with enough statistical power behind it. One more thing we did was we would actually we would look at adverbial use. So you can take all the adverbs in those different languages, and all of these different words essentially mean the same thing, namely something like indeed. And we can get that by mapping them to their translation equivalences in BabelNet. If we do this and we look again at correlation with demographic factors, we see something interesting, namely that women use their language equivalents of words like indeed, really, genuinely, or quite, while men use something like just, almost, still, or however. Now, these two groups are interesting because in linguistics, this is typically referred to as intensifiers versus downtoners. And the new aspect of this is that typically, the perceived wisdom was that this was the other way around, so that women use more downtoners and men use more intensifiers. Well, our data says no, this is actually the opposite. And again, these findings hold in this case across 4 to 5 different languages, depending on which of these equivalence classes you look at. So in this second part of the talk, what I've shown is that we can actually use large-scale statistical analysis and machine learning models to not only discover or corroborate existing theories, but also discover new ones in a data-driven manner. And that using NLP technologies such as post-tagging and parsing, we can get to levels of linguistic insights that have been suspected, but so far never shown. So we have our data set. We have shown that we can actually, or our models can automatically detect these patterns, these correlations between certain demographic groups and language use, linguistic variables. The question is now, can we benefit from that? What do we as an NLP community care for it? Initially, I've talked about fairness and that we found these differences where our post-tagging models do worse for certain demographics. We saw that our post-taggers did worse for tweets that contained African American vernacular English. So the question here is, can we actually make use of these social linguistic insights, incorporate that in our models, and then also see a benefit in terms of improved performance? Again, this is motivated by looking at the data. Is there a different behavior in what people do? These are ratings that people give, negative, neutral, or positive. And what we see is that women and older people in the older group tend to give more positive and fewer negative ratings than men and younger people. So if you want to have a review, you should ideally ask older women. Also on a sunny day, apparently that also has an influence, but we don't look at that here. So the thing here is that all these factors sort of influence how people react, and then they produce a rating and they say something in the data. But what we've done so far in NLP is we've pretended these things don't exist, and we just go from the text and try to infer this. Now, Svetlana has done some work already for sentiment analysis on this, where she showed, well, that's a wrong assumption. You should care about who said it. It does make a difference, because see the graphs I've just shown in the last slide. What I did in this paper is basically extend this work by looking at different tasks. So I look at sentiment analysis, but also topic classification, and then basically as a sanity check, if you will, I look at, if I know the age of a person, can I predict their gender better? And if I know their gender, can I predict their age better? It's not a task that you might care for in everyday life, but it's a little bit of a sanity check here. You will see that these tasks differ in the number of labels. So we have a binary task here, we have a ternary task here, and we have a 5-class classification problem for topic classification. I should say there's a huge difference in the types, in the topics that men and women, for example, talk about. If you look at, so topics in this case are for the types of businesses that people review. What we see is that I think the most reviewed business type for women is pet supplies, and for men it's, I believe, tires and car supplies. And the two distributions are basically completely divorced from each other. They're polar opposites. There's two things where men and women review relatively equally frequently, and that's hotels and fashion accessories. So we're not interested in learning a distribution over topics by gender. So what we do here is we actually control A for the number of instances from each of the different topics, and also for the total number, also for the topics in each, the male and the female group, for example, or the age groups, so that our model does not pick up on those differences. What we want is our model to only focus on the demographic differences. Our training and test sets are pleasantly huge and bulky because we have so much data, which is basically automatically annotated, so we can run a lot of it. What we did, or what I did here in order to incorporate the demographic information, is I used embeddings. It's currently very fashionable, but also it's an easy way to basically capture any differences in language use, in the distributional use, or in the distribution of words for the different groups. So what I did is separate the different groups, say men and women, or older and younger group, into two corpora, balance out those corpora because we don't want any size effects to be confounding factors. And then I created again, a mixed setting where we have equal amounts from both groups. And this is essentially the agnostic setting, the demographic agnostic setting that we have in NLP these days as standard model, right? The everything is uniform. Language does not have extralinguistic factors. And then essentially I used word2vec to train embeddings on each of these corpora. These vectors then become the only input to the classification models. I'm using a model that's based on Tang et al. Essentially what you do is you go over and do a max convolution, it's called, or min convolution. So you basically find the minimum, maximum, or average value for each dimension of your input vectors, create a new vector from that, and then you concatenate all of those vectors, and that is the input to your, in this case, logistic regression model. I should say this model is not a good model. It's not very performant. It doesn't exploit any task-specific features. It doesn't look at any subword features or anything else. So the numbers that we're going to see are not state-of-the-art. Note, though, that this is not the goal here. What we're interested in is to see what are the differences between a model that knows about or has some information about demographic differences versus a model that does not have that information. So the agnostic setting that we're using is trained on a mixed corpus using those embeddings. The other setting, the informed setting, is basically we train two models, one on, say, male, one on female data. We get those embeddings, and then at test time, we choose the one that gives us the higher performance. I also experimented with basically giving the model information about which age or gender is the one of the author. We often know that in social media settings, but it turns out that that's actually comes out to the same numbers. So the models, the smart models actually pick up on these differences even without you telling them, oh, this is written by a young person. What we see, and this is averaged over the 5 languages I used. Blue is always the agnostic model that we have. Pink is the model that has access to demographic information. As we know from Svetlana's work, sentiment analysis benefits tremendously, but also so does topic classification, which is really interesting because we have eliminated all confounding factors. So even though older and younger people might talk about different topics, in the training and test data, they're completely balanced out. So the model cannot pick up on those differences. The sole difference is the different language use of those groups. And then in the sort of sanity check, where we try to classify the gender of a speaker based on their age, again, we see that we can do a lot better if we have that information. Yes? Yes, sorry, these are accuracy scores. I should have said that. Yeah, it's missing. Thanks. The same, in short, holds for gender. Again, for sentiment, we see a nice increase. Same for topic. And for age classification, on the whole, we have 30 different settings. So we have 3 tasks, we have 5 languages, and we have 2 variables. So 3 times 2 times 5, 30 settings. In 19 of these 30 settings, the difference is actually statistically significant. In this case, I'm using a bootstrap sampling test. 10,000 times you draw a random sample, you compare the 2 systems to each other, and you check whether the original difference that you see on the whole data set holds on this subsample as well. And again, here I used Bonferroni correction because if you just do enough of those samples, you would find some to be statistically significant. Statistically significant in this case meaning statistically significant at p less than 0.01. Or if you divide by the Bonferroni correction, 0.002. So basically at any level you would choose to care about. So in sum, in this last part, I've shown that if we use social linguistic insights into demographic differences and incorporate them into our models, in this case with embeddings, there might be smarter ways, for example, with a feature model, we can improve the performance on 3 different text classification tasks in NLP. So, in conclusion, the intuition that language differs across demographics also bears out for NLP. I've shown in the first part of this talk that we can use reviews from an international user review site that provides this demographic information and text corpora to then discover the demographic differences in a data-driven way. And last but not least, use those differences to the benefit of our NLP systems to make classification performance better, to improve classification performance, and in the long run, hopefully make NLP systems that become more pervasive fairer to all the users. Are we done yet? Not quite. The things that I want to look at in the near future is basically augment this data in several ways. We can make use of census information and databases that we have externally available. We've started on that to some extent. Use other information that's particular to certain demographics. In this case, speech data, recordings of some sort, which normally have a higher degree of demographic variation. At least regionally, but probably also in the other demographic factors. And then we'd also like to take a longer view look. So compare data from young women from the 50s to data from young women in our data sets. How have things changed within a particular demographic group? There's a number of experiments that we can do, and this is probably not the end. This is more than I can probably do in my spare time. So if you're interested in collaborating, if you have some ideas, if you feel inspired by some of the things you've seen, please contact me, let me know. There's enough work to be done for all of us. And that's the end. Thank you very much for coming and for listening. Any questions? Yes? Good thing that I numbered the slides. 3, 5, 2. Other questions? Yes.
So, when you at the beginning of the talk, I think when you said that demographic information improves NLP, I was thinking that you meant if you knew the gender, then you could do better at classification. But it seems like when you were talking about your experiments, you said that you didn't actually need to tell it that at all. So, can you? What's the right picture? I mean, what do you really mean when you say demographic information? NLP mean? Because it's something about it improved the features to have the training aware of the. Can you help me sort out?
Yeah. So the difference. So what we see is that demographic differences bear out at different levels of linguistic abstraction, at the phonological, at the morphological, syntactic, semantic level, throughout the different experiments. So there is this correlation between the factors and sort of the different levels of NLP analysis. Now, including information about the variation within each demographic group can improve the performance of the models. So actually the result that we've seen here is encouraging because it means we don't even have to run like a gender or age classifier first to then tell the model, oh, use this particular submodel. We can actually just run all the submodels we have and choose the one that gives us the highest classification confidence value of some sort, probability or weight or whatever. And it turns out that that's actually the one that is correct, or was the one that correlated or for the specific group. But the fact is that these models that do best are the models that had access in their training phase to the demographics.
So really you're conjoining these demographic information things with the features you've already got, and at test time you just say, even if I just try them all, the one that works the best, that looks the most confident, that does the best, then improves accuracy.
Yeah.
So you are like increasing your feature set to have these features that maybe you don't even observe at test time, but
yeah,
anyway,
but they bear out at test time. Yes.
Can you say a little bit more, because I didn't quite understand it, what you're hoping to do in the augmentation phase with the recordings for speech to text?
Oh, yeah. So in NLP, traditionally we work with text, period.
Yeah.
Text, however, is a codified form of speech. There is a lot more spoken languages in the world than there are written languages. One side effect of this is that in most Indo-European languages, we write a writing system that has been codified sometime in the early 20th century, typically, and it changes a lot more slowly than spoken language changes, because spoken language is in a lot more use. So when we want to really track language change, when we really want to track variation across demographics, spoken language is the much richer, the much more natural data source. And so incorporating information from that would probably give us a lot more leverage. We see some of that in social media, which in many respects is closer to spoken language in terms of codification, canonicity, than, say, Newswire, right, which is extremely high register and like extremely standard language.
My sense is that you may give a gift to the speech recognition people at the same time, because the language model is really important there. If you have demographic information, I believe you could get, a higher accuracy in the speech recognition.
Oh, yeah.
So to the extent that you can find the differences and feed it back and have more specific language models according to the demographics, I believe their technology will perform better too.
That is entirely possible. I hadn't really, hadn't even thought about that aspect. But yeah, definitely. It makes perfect sense. Yes.
Anyone else?
All right. Shameless plug. We're looking for postdocs. So if you want to come work in Copenhagen, let me know. If you don't want to work as a postdoc, because you're past that, you can still come and visit us. ACL next year is going to be in Berlin, which is a short half-hour flight away, and we're always happy to have visitors. So let me know, and we can arrange something. You can give a talk, or just come visit, chat with us, and enjoy Copenhagen.
All right.
All right.
Thank you.